Okay, so we're still dealing with limits, hence the name of the unit. Um, but now we're going to, before we were getting closer and closer and closer to, 2 if we were trying to find the tangent at that point. Now, for today, we're actually going to be taking our limit and going to infinity. And we have to know all the properties that come with that. Now, this first part is review from grade 11, infinite sequences. Now, first of all, let's talk about a sequence. A sequence is a list of numbers separated by commas in definite order. So remember, it'd be term 1, comma, term 2, comma, term 3, dot, 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 all the way to Tn. Okay, now that is what we would call a finite sequence. If it just ends in dot, 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 that's infinite. And if you remember from grade 11, some of them we were actually able to figure out the sum of them if they were infinite, which most people that doesn't seem probable, but if you do remember back, there are certain types that we could, and we'll talk about those again today. Remember, this is what we would call our first term, also called, what was the variable for the first term? You guys remember? A. Okay, and this would be the nth term. In this case, looks like the last. Now, there is a general term or general formula, usually given by Tn is AR to the n minus 1. That would be for a geometric sequence. Okay. Now, sometimes they can be a lot fancier than that, as an example of this. Okay. And it says we'll find the first 3 terms. Now, to find T1, you see where n gets replaced with 1? Well, throughout your formula, you're going to replace it with 1 as well. Negative 1 times 1 plus 1. Okay, so this will give you 1 minus 3 over negative 1 squared, which will give you negative 2 over 1, which equals negative 2. Okay, T2, 1 minus 3 times 2 over negative 1 times 2 plus 1. Okay, so that's equals 1 minus 6 over negative 1 cubed. Well, that's positive 1 minus 6. And that's negative 5 over negative 1, which equals 5. Okay, so I should come up and say that this is for a geo. We also had an arithmetic, if you remember. Does anyone remember the arithmetic one? A plus n minus 1d. That's the arithmetic one. Okay? So when you are adding every time, you're going to use arithmetic. When you're doing geometric, you're always going to be multiplying. Okay, and then T3, kind of short on room here, equals 1 minus 3 times 3 all over negative 1 to the 3 plus 1. So that's 1 minus 9 over negative 1 to the 4, which equals negative 8 to the 1, which equals negative 8. Okay, so those would be our first three terms. Now, how do you find Tn minus 1? So let's kind of do that right here. All you do is you put in, so t to the n minus 1 equals 1 minus 3 to the n minus 1 over negative 1 to the n minus 1 plus 1. This would equal 1 minus 3n plus 3 over negative 1 to the n, because those negative 1 and positive 1 cancel. This would equal 4 minus 3n all over negative 1 to the n. Okay, that's just a review of how to use those formulas. Next, infinite sequences. If a sequence continues indefinitely, the general term can, but not always, approach a value of L. Okay, so if you went T1, T2, T3, all the way to Tn, as n approaches infinity, sometimes limit as n approaches infinity of Tn does equal L. Sometimes. So let's go and investigate what we mean by sometimes. How can we tell? Okay, now we're going to learn some basic principles of dealing with infinity. If you take any number in the world and divide it by infinity, what would you get? 0. Okay? So if you took one pizza divided by an infinite number of people, it does equal 0. Now, basically when we're talking about limits, because basically if you really want to talk about true theory, in true theory, if you had an infinite number of people and one pizza, everybody would get a little bit. Okay? They're not going to be happy with what they get, but they would get a little bit. Okay? Now, there's 4 important infinite limits. Now, if you have a constant, so if you're, well, I could do the graph of it. Say we had a graph, and this was 7. Or if we had a sequence that was going 7, 7, 7, like that, would you know what the infinite number would be? It would be 7. So when your limit is a constant, when you go to infinity, I guarantee you it is still that constant. So if you had the limit of infinity, n goes to infinity of 7, I should have put t infinity here. That would equal 7. Okay, not a very difficult concept, but the rest kind of take a little bit more thought. So we're looking at 4. That's the first one. The second one, when you have 1 over n to the r, where r is greater than 0. What would this equal if n went to infinity? So maybe you need to wrap your head around this a bit. Okay, well, that would be 1 over infinity squared. That's an example, right? It should equal 0, you would expect, right? If 1 over infinity equals 0, 1 over infinity squared is going to equal 0. Okay, so this will equal 0. Okay, so you have to know these rules. Number 3, what if r is between -1 and 1? This is actually quite similar to number 2. So no, maybe an example would be best here. What if we did, well, this example right here. 1/3 to the n. Okay, so this is the same thing as 1 over 3 to the n, correct? Now you could say 1 over n, fine, but 1 over n is going to equal 1. So what is this going to equal? This will equal 0 as well. Okay, so if r is a fraction, now what about something like this? What if you did 3/5 to the n? That's like a small infinity divided by a large infinity, right? So who would win? The bottom or the top? The bottom. So even this will equal 0. Okay, and number 4. So if r is a number greater than 1 or less than -1, what is going to happen if n approaches infinity? So what is 4 to the infinity? What would that equal? Okay, so for the answer, we don't say infinity, we would say that it doesn't approach anything. So we would just say, okay, so if I ask you what number, I want a specific number. Okay, infinity is not a number, 0 is, and that's why 1, 2, and 3 equal 0. It does approach 0. That is a specific number. But there is no specific number. 4 to the infinity is not going to give you a specific number. Now, there is a strategy to be able to find out if your answer is going to be 1, 2, 3, or 4. Now, 1, 2, and 3 are all the same answer, right? But will it be 4? So let's go and try some of these. So if we had limit, okay, stop the whispering, you guys, and pay attention here. If limit x, that's supposed to be an n, okay, these should all be n's. Because if x going to infinity, it doesn't really apply, because there's a bunch of n's. So this would be, what would infinity over infinity plus 1 equal, do you think? So we've got undefined, we've got 0, we got 1. Now, here's a strategy that works very well, actually, is what is the largest, you see example 2 would be the easiest, but the largest power in this is n to the 1. So here's a strategy that you can try. So limit n goes to infinity. I want you to take every n and divide it by the largest power, or everything divided by the largest. See, n to the 1 was the biggest power, so I'm dividing everybody by n to the 1. Now, as a limit, as n goes to infinity, we can solve each one of these. What is n divided by n? Or what is infinity divided by infinity right here? That would be 1. Right here, infinity divided by infinity would be, and what's 1 divided by infinity? Okay. Now, example 2 starts to get a little bit more confusing. What is the largest n power? 2. So I want to take every single term and I'm going to divide it by that, and you'll see if it equals either 1, 0, or does not exist. So equals the limit as n goes to infinity. Oops. So I've got n squared over n squared minus n over n squared. And I've got 2n squared over n squared plus 1 over n squared.
We have a wrap program course.
Okay, so as limit as n goes to infinity, okay, n squared over n squared minus, now this can reduce if you wanted to be 1 over n. So what does that equal? 0. Okay. What would 2n squared over n squared equal? 2. And 1 over n squared. So the answer to this would be 1 minus 0 over 2 plus 0, which equals 1/2. Okay, so let's go up and write our rules now. So the strategy to do these, divide the terms by the largest power or degree. Okay, so n over n's will equal 1, and 1 over n's to the r will equal 0. Okay, and then say 2n over n would just equal 2. And that just even works just from algebra, right? There's actually even another shortcut to do these, but if you ever are in doubt, just do this, and even the shortcuts that I'm going to give you at the end of this, if you forget them, this always works. Okay? So I just want everybody to try example 3 right now and see what answer they would get. What are we getting? 3/8, yep. So your limit as x goes to infinity, so it's 3n over 4, n over 4, minus 2n, n to the 4, plus 1, n to the 4, all over 8, n to the 4, minus 7, n to the 4. Okay? Now, you can see that it's going to, once you put infinity in, you will get 3 minus 0 all over 8 minus 0, so you will get 3/8. Now, there's a much quicker way to do this one. Just by looking at it, you would know this is 3/8. So, if the largest degrees are the same, top and bottom, okay, you just get rid of the n to the 4s. Okay, so let's go down here. If your top degree equals your bottom degree, the limit is the coefficients of the highest degree terms. So let's just put an example here. If I had the limit, x goes to infinity, 3x to the 5 over 9x to the 5. And even if you had plus, you know, it will just equal 3 over 9. As long as those are the biggest coefficients, and they are equal. If there was a 12x to the 6 somewhere in the bottom, somewhere else, I am not going to be doing top degree equals bottom degree, because there's an x to the 6 in the bottom. Therefore, we're running into a different scenario. Okay. Let's go up to example 4. Now, by the thinking that I just gave, what would you think, instead of doing all this work, because we could take everybody and divide by n to the 7. That will work. But a quicker way to do it is take your largest coefficients, which would be 4n to the 5 over 2n to the 7. Now, if you divided those by n to the 7 even, that'll give you an idea. But what would you expect this to equal? Because the bottom is way, way, way larger, right? When you put infinity in there. So this does give you 0. Okay? And you can even check, right, if you had 4n to the 5 over n to the 7 over 2n to the 7, n to the 7, this is going to give you 0 over 2, basically, which would equal 0. So let's go down to our rules. If the top degree is less than the bottom degree, the limit will equal 0. So example, x to the 3 over x to the 5 will equal 0. Okay, now let's do example 7, because example 7 will illustrate the last one. But we've been focusing on the biggest degrees of each. So n to the 4 over 9n squared. As we go to infinity, which one's going to be way bigger? The top, okay? So it would be the top divided by a smaller, right? Which is it going to approach 0? Is it going to approach 1? It will not exist, right? Okay, and another way you can actually show that it doesn't exist is by using our, because that would be n to the 4 over n to the 4 divided by 9n squared over n to the 4. That would equal 1 over 0, right? And 1 over 0 is undefined or does not exist. Okay, and again, these are all supposed to be n's. Okay, so our bottom one, if our top degree is larger than our bottom degree, limit does not exist. So I had x to the 5 over x to the 3. Okay, again, that'll just equal. Okay, so we've got some examples to finish up here. So in example 5, what I do is often just write out the biggest ones. So this would be 8n to the 10 over negative 2n to the 60. What should this equal according to our rules? 0. Example 6, I would have n to the 5 over 2n to the 2. This would equal, does not exist. Okay. This one's a little different. Why don't we multiply this out? This would be 10 minus 10 times 3 to the negative n, which would equal 10 minus 10 over 3 to the n. I guess limit as n goes to infinity. Okay, what would be the answer to this then? It would be 10 minus 0, which equals 10. Oops, was there a negative 10 in there? No. So these patterns, yes, you should memorize them. But if you ever kind of lose your bearings for a second, just divide everybody by the largest, and then you'll get it back, okay? So there's your assignment for a Wednesday/Friday. You should be able to get her done.